Hey everybody, this is Larry. This is day 19 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, non-overlapping intervals. Yeah, two things. One is, of course, guess where this is from? The drone video, obviously. I'll leave it, I'll come in at the end, as usual, so have fun with that. The second one is that I think people who watch me for a little bit knows that I do a lot of sweep line algorithms, even on algorithms that people might not solve that way. And for non-overlapping intervals, it is probably one of the probably one of those cases where that is the most, right? I think the critical part is. I think the critical part is trying to figure out how to rephrase it in terms of structure that we can kind of think about, right? This one, this one is a little bit tricky depending on how you want to do it. The constraints are 10 to the fifth, so it suggests that you have to be a little bit fast enough to do it. So like you can't do any n square algorithm, which would be too slow. And so you have to try to reduce it in a way such that you for every interval you have to make a quick decision, right? There's no branching, because anytime you do any branching, you're already probably too slow unless it's dynamic programming or something like this, where you can take advantage of the branching using what they call overlapping sub problems, right? Which so that the branching is okay, but failing that, yeah. So we have to kind of be pretty fast, right? The first thing that I may think about is kind of some sort of given any regular interval, we want to figure out if there's some sort of structure that we can impose to it, and of course that just begins with sorting, right? And once we finish sorting, what does that mean? Well, the thing is that this is one dimension, right? Because this is one dimension, it means that there is some sort of a forcing function. I think another way to phrase this also is that now that I think about it, I think I'm a little bit slow on getting to this point, or at least slower than I don't know. Maybe I'm just slow these days anyway. But the way that I would maybe retool myself to think about is that instead of finding the minimum number of intervals that you have to remove, you're trying to find the maximum number of intervals that does not overlap, that you're keeping, right? So you want to maximize the number of intervals you keep instead of minimizing the number of intervals you remove. And in that world, what does that look like? That means that we greedy is hard to prove. I'm trying to think about how to kind of get it right. So basically, if there are multiple intervals that start at the same place, to get more intervals, we clearly want to keep the shorter one. But is that enough? This is kind of tough. Let's say we're going from left to right in a sweep line thing. what does that look like on a greedy thing, right? So let's say we have a thing, okay, so we basically will keep the one that extends the least out, and then you have to remove the other one. So then basically, okay, I see. Wow, this is not an easy one, to be honest, if you ask me. Well, I always have trouble with, I feel like if you're only watching me this week or this month, I've been describing every type of problem as my weak point. But it is kind of been that kind of, right? So, because linked list is definitely one of my weak points, just because in competitive it doesn't come up, and in real life it doesn't really come up as much. And greedy is just tough to prove correct. And here, I think in a greedy way, if you're trying to calculate the max number of intervals that does not overlap, then you basically just keep track, almost like implement using a stack. You don't really need a stack because of the same thing that we talked about, was it yesterday or a couple of days ago, where you don't, it's memoryless to a degree. So if you only keep track of the last interval, you know that everything before that interval, well, you already know that they don't overlap, right? So it's fine. So that means that you only keep track of the last interval. That should be good enough. Because that means that if you have to make a choice between two intervals, then you always keep the one that extends least out, because that means that in a greedy kind of way, is that true though? Oh yeah. You want to keep the one that's left out, because they're probably greedy is hard to say and prove. Sorry, fans. But basically, there are only 4 cases, right? Let me actually draw this, because I think. I'm convinced, but I feel like I don't think I'm doing a good job convincing you at home, right? So basically, okay, let me try to rephrase this also. Let me try. Why is this like cable so short? Okay, hang on. Also, what would be helpful is if I put it on screen. So hang on for that too. Okay, so let me start, not all over, but from the part where I said, okay, so let's say we have a line, right? And we have a lot of segments, you know, and let's say that we're looking, and the last segment that we care about was this one, right? And because of this one, and we're going from left to right, by definition, that means that the other segments that we're considering will be after that and so forth, right? And because of that, we also know that we don't have to care about anything before this. In that sense, it's memoryless, because we know that by definition, that this does not overlap with any of these here. That means that nothing after nothing after these will be overlapping with these, right? Hopefully that part makes sense. And that, because I think that allows us to that allows us to kind of just focus on the last segment, I believe, right? Unless I'm like really wrong and missing a case. And okay, so then now, because of that, we can just do like one by one. So we only have to just consider, whoops, sorry. We just have to consider this segment, right? And this segment, and there really is only a couple possibilities, right? So basically, you know, let's say we have this segment, and then there are only a few possibilities. So it could be like this, it could be like this, and that's it, right? Because by the definition that we already sorted going from left to right, these are the only thing. I mean, maybe you can also separate a case for if they're on the same thing, but I think that it's, for most purposes, without loss of generality, is the same thing, right? So in this case, in this case, and you can maybe separate it, and this is almost like a proof by, what's it called? Like, is it by exhaustion? I'm thinking of the wrong words today. Like basically like you're doing every possible case, right? That's your proof. And basically the idea is that in this case, we want this segment. Why? Because as we said before, this is the starting, this is the starting. They have the same property that it doesn't have overlap with anything in before that. But looking forward, it just has more, in a greedy kind of way, it just has more space of like, you gain this gap of possibilities, right? Meaning that in theory, if you wanted to add like more segments, like if there's a segment that like this will be good for this one, but not this one, right? I mean, hopefully that makes sense. It's just very greedy in that way. And then now looking at the other one, looking at this one, in this case, by the same logic, again, we don't have to care about anything before, but then now we have this gap or whatever you want to call it. In this case, we always want to choose this one because it can only improve your result in the same logical, greedy way. And so that means that, and you can, in theory, implement this as a stack, as I was saying, but I don't think it's possible. I mean, because none of the stuff overlaps, you don't go more than one step back, so you don't have to care about the last segment. Yeah, and I think in that way, you just kind of keep on extending it, and then now the problem is just maximizing the number of non-overlapping thing, and that's basically what I mean by converting it to maximizing it. Makes it, at least for me, quite a bit clearer. So okay, so now we have to sort. All we have to do is sort by X. We're going to sort by Y because we get to sort by Y for free, but for all purposes, I think it doesn't really matter. As long as you sort by X, and then we kind of keep stuff based on the Y that comes up, right? So okay, so let's take a look at this. So in the rows, like we said, we sort, and that should be good, which is the magic of Python, I suppose. And N, right? And then maybe like a keep is equal to 0 for now, right? And then maybe I don't know, extends to, or like naming things is hard. What we're trying to do is figure out how far we extend this to. So like maybe farthest is equal to negative infinity, right? And then okay, and then now you do for start, and I almost wrote x, y, s and d is maybe not that much better, but yeah. So basically now, if s is greater than or equal to the farthest, that means that we get to keep this. It's a new segment. Yeah, and that means that we increment by 1. We set farthest is equal to y, right? Else, what happens? Else, that means that this overlaps with the last segment, and then now farthest is equal to farthest or min farthest, and y, we overlap, so we pick the farthest, we pick the one that is smaller or closer to the left, right? Closer to the left in a greedy way, right? And yeah, and here we do not, by definition, because they overlap, we only get to keep one of them, and because we only keep one of them, we don't have to increment keep because we didn't keep anything new. So then now at the end, we can the number that we remove is just n minus keep, and I think we should be good. This code is ridiculously short, and yeah, this code is ridiculous. And what I mean by that is, oh, this is slow apparently. Maybe there's a easy way to do it. I don't know. Meh, I don't care. But this is actually ridiculous now that I typed them out, because this is one of those things where I talk about this from time to time, where you look at someone's code and you're like, oh wow, this is a really easy problem. It is 10 lines of code. But if you don't really get the logic, if you don't really get the proof, that's the basis of doing well in interviews and projects, and I mean not projects, and competitive programming, right? I mean, in interviews, obviously they'll just ask you to explain it, and if you're unable to explain it, it doesn't matter how good your code looks, right? I mean, part of the coding interview is communication and trying to get, and especially nowadays with ChatGPT and all this stuff, people are trying to make sure you're not cheating and stuff like this, right? So yeah, so look at this code. You're like, oh wow, it is only like 10 lines of actual code, but as you can see, we took 15 minutes to kind of explain it to you, right? So, what else? What was the other thing I was going to say? I forgot. Oh yeah, and for competitive, obviously it's just a good thing. Otherwise, you're going to keep on guessing at answers and hoping that you're right without proofs, and you're going to get like 10 wrong answers. And which is maybe it's fine and it's good in the beginning when you're still learning and you're still growing. But at a certain point, those penalties going to, they cap how your ceiling is, right? So yeah, cool. That's all I have for today. Let me know what you think. Stay good, stay healthy to the good mental health. Wow. Stay healthy to good mental health. And yeah, so the drone video is from a lake about 2 hours from Bishkek in Kyrgyzstan. I got a comment the other day, a couple of days ago, saying, and I was in Kyrgyzstan like, nowadays, maybe a month ago now. So yeah, it's beautiful. Would definitely, recommend it. But yeah, sorry I missed people who were there though. Would have loved to meet up, but anyway. That's all I have for this one. Let me know what you think again. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.